Welcome back to day 9 of Advent of Code, and today, as usual, we've set up the basis for our code, and we have a very interesting problem today, which is some kind of encryption. This looks very complex. The problem statement looks complex, but basically we need to just store 25 numbers, like something which is the preamble, and then for each new number we need to check if this new number is the sum of two numbers that are in the previous 25 numbers. Although here it could be only 5 numbers, so we need to be careful about that. So we're going to do that. I'm going to create a class for starters. Not sure exactly how we could name that. Let's just name that Christmas, because this is the name of the protocol. Here, constructor. What we're going to feed to the constructor is the preamble. I'm going to say this dot array. When I don't have a name for a variable, I just call it the same as data structure. And here we're going to say is valid int, and we're going to have to do here the logic here, and then we're going to have something push int. And the interesting thing is going to happen here as well, which is we're going to say this dot array dot push int and this dot array dot shift. And what we do is that we're going to add something at the end of the array, and shift is going to remove the first element of the array, which enables us to have always the array of the same length. So if at the beginning we feed 5 numbers into the array, that's not a problem. There will always be only 5 numbers there. So hopefully this should be quite good. As usual, we copy paste this, and we're gonna not implement that right away. We're gonna handle these lines here. So we should map that to a parse int, which is something that we haven't been doing in a couple of days. That's why it's not there. So we have now an array of integers, which is 1 integer per line. Now we need to take the first x elements, so that's going to be 5 elements at first, and we're going to create this const xmas equal new xmas. Oops, xmas equal new xmas. Yes, and here we provide the first 5 numbers, and we're going to do a for loop, simple for loop here with I that starts at 0, that goes through each lines. Actually, it doesn't start at 0, it starts at 5. So here we're going to say const preamble length, and it's going to be 5 here, because this is something that we're going to change for the full computation, meaning here we just take the 5 numbers because the preamble is length 5, and later down the road the preamble is going to be 25 length. So here we're going to say xmas, we're going to say if xmas that is valid element, then xmas.push element. Otherwise, we're gonna console log the elements, and we are going to break out of this loop. So now we just have to code this isValid function, which is okay, everything is fine. So here we're gonna stay within this function, and we are going to make this work. So we need to make sure there are 2 numbers that add to this value. So here I'm not going to be doing something very complex. We're just going to be doing a really like for loop. So this is going to be this dot array, and then here we're going to have another for loop. j still this that array, and j is going to start at I plus 1. This is going to give us all the possible combinations of two numbers in this array, and at that point we can say if this dot array of I plus this dot array of j is equal to int, in that case we return true, and otherwise we'll just return false. So that should do it. Let's just run that day09.js. Okay, some little typos. I think that should be good. 127, let's see, is that correct? 127 is the number that was expected, so we're good. Now time to get the full puzzle input. Okay, let's run that. Now we need to run that with the preamble length of 25. We get this big number. Let's input that in here. That's good. Let's go to part 2. So now we need another type of invalid number, a contiguous set of at least two numbers sum up to the wow, this is interesting. So here we need to keep this invalid number, which is 127. So we're going to keep that and we're going to store it somewhere. Let invalid, we don't initialize it. Here we're going to say invalid is equal to element. So now we can console log this invalid number here for part 1. Now we need to find two numbers that are next to each other that sums to a contiguous set of at least two numbers. So it could be more than two numbers that sum up to 127. So that's actually going to be an interesting challenge. Because if this is just two numbers, it's easy. We just go through everything, we check the number and the next number, and we check if the sum is 27. But that's not good. Here, this should be a contiguous set. So we need to find this set. I need to add the smallest and the biggest number. So here from 15 to 47. So 15 plus 47 is equal to 62. So that's a good challenge. So it could be the full set. I think what we're going to be doing is we're going to check. We're going to do something that's not super clean, but basically we're going to take length equals 0 and below xmas dot array dot length. So what we're going to say is we're going to check first of all to add two consecutive numbers, and then we're going to increase that to 3 consecutive numbers, 4. So that might take a bit of a long time to run. That might not be the most optimized solution, but I think it's just gonna be fine if we do that. So here we need to go to xmas.array.length minus length. Let's call this, instead of length, let's call this L, otherwise that's going to be confusing. So let's say here we have length of 2. I think there's like an off by 1 error that can happen here. I have gut feeling that this should be L minus L plus 1, because if we have just 1, then we need to go to the end of the array, and if we have 2, then we need to go to length minus 1. So that's correct. And here what we're going to do, I guess we need another for loop. Let sum equals 0. And here we're going to say for j between 0 and L. What's going to happen here is we're going to say sum plus equal, and so this is the position in the Christmas array, so position I, and then we go, oh wait, so yeah, we go from I to I plus L, so it's I plus J. This is the sum, and here we're just gonna check if the sum is equal to, I forgot what is in the prime statement. It needs to be equal to the invalid number from step 1, from part 1. So this, if this is equal to invalid, in that case we can stop everything and sum the smallest and largest number in this contiguous set. So here const set is equal to, so here we're going to extract the set from this array, and this is going to be, we slice from I to I plus L, and then we can say const, what is this in the end? What is this number that we need to find? Encryption weakness. So const, oh, actually let's say here, let weakness, and here the weakness is equal to math.min of this set plus math.max of this set. So here set is actually just an array, not a proper set object. Smallest, and we just need to add both of them. So here we can just log the weakness. Let's see how it goes. This is undefined, so we have an issue. So we're gonna fall back to the test example. Here we want to use a preamble length of 5 for this test example, and we're gonna run that. What I think we're gonna do here, we're gonna log I, we're gonna log L and sum, maybe Li sum. This should give us, so here we check what happens if the length is 2 for each element of the array. 0, 1, 2, 3. Let's check. Okay, so this is 1, 2, 3, 4, 5. This is the preamble. So all of this is not the preamble. This is the rest. Interesting. Oh, my bad. I think here I am using the Xmas array, and this makes no sense. So here we say const preamble is equal to this, and this is something that we want to reuse here, and const the rest of the array, rest of array is equal to, we're going to do a slice again from preamble length to the end of the array, and this is actually what we care about. We kept only a piece of the array in our xmas.array, and we want to go through the full array. That was my mistake. So here this is rest of the array, rest of the array, rest of the array, and one more time rest of the array. So the little optimization to only keep part of the array in memory was not awesome because it made it a bit more complex for our second step. So now let's see. I have a lot more lines, and this is what I was expecting. So here we should have numbers from 0 to 13, okay? Before we dive manually and check everything, we need to have length 4 from, oh wait, does this, yeah, this considers the preamble. So here I shouldn't be using the rest of the array. One more time, this is a mistake. I should use lines directly. So that was my mistake. So that's just really like part of the prime statement, really trying to understand what input you need to use. Let's try that again. Okay, so now we have an answer. I'm going to remove the console log to keep things really clean. The answer is 62. Let's see here. The answer is 62 as well. So I guess this is time to get the full input and try that again. Here we have to remember to change the preamble length to 25, otherwise it's just going to break and it's going to be sad. Let's check if, oops, let's check if this number is the right one. It is! So this is it for day 9. Thank you very much for following. Please drop a like and see you in the next one. Bye bye!